Hello. In this video, we're going to look at graphing radical functions. To start off, let's graph the easiest radical, y equals square root x. Now to do this, the best thing to do is start with a table of values. So over on the side, we're going to go ahead and have our x and y table. And for x, we can pick, just 0, 1, 2, 3, just some nice easy values. And for y, we square root the values. So the square root of 0 is 0, the square root of 1 is 1. But the square root of 2, well, the square root of 2 is actually like 1.4 approximately. That's not really a nice value to graph on the graph. And the square root of 3, that's like 1.7 or something, but you need a calculator. I would say it's not until you get to the square root of 4 that you get a nice value too. And so I'm not going to worry about the values 2 and 3 because they don't graph very nicely, but 4 graphs pretty good. And if you wanted one more point, you could do x equals 9 because 9 is going to be the next number that gives you a nice square root of 9 being 3. But depending on the size of your graph, that point might be optional. Now let's go ahead and plot these points on the graph. We have 0, 0, 1, 1, and 4, 2. From here, we just connect the dots, and we have our first radical graph. A few things to note about this graph. It doesn't continue here on the left side of the x-axis. That's because you can't square root negative values. And also, it has sort of this smooth shape to it. It's not a line, it's a curve. It's kind of got this trajectory. It almost looks like you're throwing something, or if you turn your head sideways, it looks like kind of like a sideways parabola. So make sure when you draw the graph, you have this smooth line, and of course, make sure you have an arrow. Now, what about something like this? Y equals the square root of x minus 2 plus 1. Well, initially, you might be thinking, oh man, there's all these extra numbers, I'm going to have a really complicated table. But what we want to do is think about graphing this using transformations. The original graph looks like square root x. This graph has a minus 2 and a plus 1. And if we think about it in terms of transformations, this minus 2, because it's next to the x, is a horizontal translation. And the 1, because it's outside of the square root, is a vertical translation. In other words, we're going to move the graph 2 units to the right, and we're going to move the graph 1 unit up. Well, that's just transformations. That's as though we had y equals f, x minus 2 plus 1. And transformations are something we've done before, and hopefully we're pretty familiar with. The only thing you need to do a transformation is you need the base graph so you can apply the transformations. And so in that case, we need to somewhere write down the original base graph, x and y. So we're going to have, let's say, 0, 1, and 4 for x, 0, 1, and 2 for y. Those are our base coordinates, or the base graph. If you wanted to write them as coordinate pairs, you'd have 0, 0, 1, 1, and 4, 2. Now we simply take these points and transform them. We move the x value 2 to the right and the y value up 1. So this becomes, well, I can write it right here. The x values are going to go up by 2, and the y values are going to go up by 1. So that becomes 2, 1. This becomes 3 and 2. And here we get 6 and 3. Now we take those points and we plot them on the graph. 2, 1, 3, 2, and 6. 1, 2, 3, 4, 5, 6, and 3. Connect the dots, and we're good to go. Visually, of course, we can see this graph has been moved 2 to the right and up 1. And it's got the same overall shape because we haven't done any stretches to it. We've simply translated the graph. Now, an equation like this is a little more complicated, and that's because the transformation hasn't really been written properly. We need to have a bracket inside the square root because there's something next to the x. And so instead of writing negative x plus 4, really this should have been written as the square root negative bracket x minus 4. That way the negative is outside, and we can see that we're not having a plus 4, we're having a minus 4. But once we do that little trick and rewrite it properly, we can recognize the transformations. In front here, we have a horizontal reflection. Inside here, we have a horizontal translation. And at the very end, of course, we have our vertical translation. And so each one of those transformations will be applied to our basic graph, and we'll have our new graph. Now I encourage you to pause the video and go ahead and try to do these 3 transformations yourself and see what you come up with for your graph. All right, hopefully you gave it a try. The points you're starting with are 0, 0, 1, 1, 4, 2. Now the reflection in the horizontal means we have to multiply all the x values by a -1, or in other words, we have to make them negative. And then we have to do the translation, which means we have to add 4 to them. For the vertical values, we simply have to subtract 5. So let's go ahead and do that one at a time. Making 0 negative doesn't do anything. Adding 4 moves it up to 4 and down to 5. 1 becomes -1. Adding 4 becomes 3. And then 1 minus 5 will be -4. -4 plus 4 will be 0, and we'll have -3. So let's take those 3 points, 4 and -5, 3 and -4, and 0 and -3. Now we connect the dots, and we have ourselves our graph. Again, visually, we can see a horizontal reflection, and we can see a translation of 4 units to the right and 5 units down. Here we have another radical to graph. And again, as long as we can recognize the transformations, we should be all right. Go ahead and pause the video and see if you can come up with the sketch of this graph. All right, so let's start with our base points, 0, 0, 1, 1, 4, 2. Now the 2 in front is going to represent a vertical stretch, and then the 1 in the end is going to be a vertical translation. So that means here, this 2 means we're going to have to multiply the y values by 2, and then we're going to have to subtract 1. This 2 inside means we're going to have to subtract 2 from the x values. All right, let's go ahead and do that to each one. So this becomes -2. 0 times 2 is 0, and then -1. Here, when we multiply by 2, we get 2. Oh, sorry, when we subtract 2, we get -1. Multiply by 2 and subtract 1 gives us 1. And then subtracting 2 is 2. Multiplying by 2 and subtracting 1 is 3. So now we have our points. Let's go ahead and plot them on the graph. -2, -1, -1, 1, and 2 and 3. Again, we connect the dots with that nice smooth graph. And you can see this graph is a little bit taller than the base graph, and that's because of the vertical stretch by a factor of 2. All right, again, we have another radical to graph. Please pause the video and give this one a try. All right, let's look at our points. 0, 0, 1, 1, 4, 2. In this case, the 4 on the bottom is going to be a horizontal stretch, and we have to remember that it's going to be the opposite. So we're going to multiply the x values by 4, and then we're going to add 5 to them, whereas for the y values, we're simply going to add 1. So the y values become 1, 2, 3. The x values become 5, 9, and 21. Now the first one's not too bad to graph, but the next one's going to be a little tricky. It's off the grid that we have here. So our grid only goes up to 1, 2, 3, 4, 5, 6, 7. So we kind of have to extend the grid this way, 8, 9. So it's sort of running into our points here. And the 21 and 3 is certainly going to be off the graph. So the best we can do is connect these 2 points. Maybe I'll do it in another color so we can see here. And then in this case, because the 21 and 3 was so far, 2 points will be good enough. All right, here we have one more really complicated one. We have negatives, we have 4s, 2s, all sorts of transformations. Please pause the video and see if you can come up with the correct sketch. All right, let's go through this. 0, 0, 1, 1, 4, 2. Now we're going to have to do a lot to each value. The y values get multiplied by -4 and then added 2. So let's do those first. 0 times -4 is 0 plus 2 is 2. 1 times -4 is -4 plus 2 is -2. And then 2 times -4 is -8 plus 2 is -6. Now we'll do the x values. We have to multiply by a negative, and then we have to subtract 4. So we should be getting -4, then -5, and then 4 makes -4, subtract another 4 is -8. Let's go ahead and plot these points. -4 and 2, -5 and -2, and then -8. That should just be right off the graph a little bit, and then -6, just over here in the corner. And we'll connect the dots and add an arrow. All right, so hopefully this makes sense in terms of graphing radical functions. You can go ahead now and try worksheet 2 and worksheet 3. So worksheet 2 and 3. As well, when you're done, you can always work on 2.5 and 3.5 for homework. Thanks for watching.